Hello everyone, welcome to the lecture on machine shop as part of your curriculum for workshop or manufacturing practices. I am Dr. Manish Mukhopadhyay and we'll be learning about the different jobs you need to perform as part of the experiments on machine shop. Okay, uh, so let us jump into the experiments which you need to perform. The jobs or tasks expected. The first task which is expected is step turning on lathe. Step turning on lathe. Okay. What you need to do? You need to make a pin like this from a cylindrical block of mild steel. The second thing which you need to do is to make a rectangular slot on a block of cast iron on a milling machine or using a milling machine. Suppose this is a rectangular block of cast iron where you need to make these kinds of slots. What are they used for? Why do we need to make these slots? We'll be discussing about them in the later slides. Okay. Now coming on to the third slide. Now we will be discussing about the first job, that is step turning on lathe. I think you now know what is the job you need to prepare. Let us revisit the first slide. This is the job you need to prepare where specific diameter and or dimensions of the pin are provided through this engineering drawing which is given to you. Okay, so where we need to perform this task, we need to, in order to perform this task, we would be requiring a mild steel rod, and the step turning operation will be performed on a machine tool like this known as a lathe. L-A-T-H-E given over here, lathe. Okay. Now, what is mild steel? Mild steel is a type of low carbon steel. Now, carbon steels are metals that contain a small percentage of carbon, which enhances the property of pure iron. The carbon content varies depending on the requirement of the steel. Mild steel contain carbon in range of 0.05 to 0.25%, making it malleable and ductile. Mild steel has a relatively low tensile strength, and it is cheap and easy to form and easy to work upon. Whenever you are going to perform any machining operation on mild steel, it is generally considered to be easier compared to some other variant of iron. Okay, and there are variety of applications of this material. Okay. Now coming on to what is this machine tool, this lathe. What is a lathe? Lathe is one of the most versatile and widely used machine tools all over the world. So basically it is a machine tool. Okay. What is a machine tool? A separate video has been prepared about lathe, the type of cutting tool, what is a machine tool. I'll be giving the link of that video in the description box. Kindly check it out. Okay. Then
you need to update Bixby Basics.
Sorry. It is commonly known as the mother of all machine tool, this lathe. Why it is known as a mother machine tool? Because it is said that using lathe, a new lathe can be prepared. Around 80 to 85% of the total parts of lathe can be manufactured using proper jigs and fixtures on lathe itself. The main function of a lathe is to remove material from job to give it a required shape and size. We'll be doing that. We'll be removing material from these kind of rods or shafts in order to perform that step turning operation. On lathe, the job is securely and rigidly held onto the chuck. There is a chuck. In the next slide, we'll be learning about these in details. Okay, either they are held in the chuck or between the two centers, uh, and then turn against a single point turning tool or single point cutting tool. This, you can see there is a tool post where a tool is mounted. How a tool is mounted and how does it take part in cutting action, we will be seeing in the next slide. Okay, and with the relative interaction of this tool and the workpiece, the job, okay, this job, what happens is material gets removed from the workpiece. The process can be visualized or is very similar to sharpening of a pencil. Okay. There is a shaft, there is a rod in shape of a pencil. Whenever it is inserted into a sharpener and a twisting motion is given onto the pencil, material removal occurs from the surface of the pencil. That's why we get the chips out of the sharpener. Okay, now what are these? Let us see in this in details. Okay. Now, principal parts of lathe. What are the principal parts associated with lathe? I think it is visible over here. There is a diagram of a lathe here. These are change wheels. This portion is known as your headstock. This is your lead screw. This is saddle, compound slide, cross slide, rack, tailstock. What are these? This is the bed. Okay, what are these? Let us see this picture again. I've said that what? Change wheels. Where are change wheels located? Inside this box. This portion is your headstock. Compound rest is this. Okay, cross feed is given over here. This is the longitudinal feed. This wheel is used for the longitudinal feed. This is the tailstock and this is the lead screw. Okay, now different speed and feed can be achieved from this lathe or can be controlled on this lathe. The rotating speed of this chuck when the workpiece is mounted and the traveling speed of this carriage, the carriage which holds the tool post and the tool. This can be adjusted by changing the levers over here. Okay, so let us see a video in order to understand this a little better. Now to play the video. This video is on lathe components. This is the bed of the lathe. This one. From this side and from here to here. It is the bed of the lathe. Now you can see this from this to here. It is the bed of the lathe. Okay. These are the bedways. They are used for easy movement of the saddle. See here, there are different inverted V-base bedways where the saddle or the carriage moves on the bed surface. I think you have learned about, I presume that you have learned about these beds or this fitting joints in the fitting shop, which you should have already completed by now. These, as I was telling, these are the inside this headstock. There are different gears and belt pulley system which are controlled by a main motor. The power for the movement of this chuck as well as this saddle is provided by this main motor. The motion from this motor is given onto this gearbox using a belt pulley system. This is the part of the headstock. And the end of the headstock, there is a spindle. On this spindle, generally a chuck is loaded. What is a chuck? Chuck is basically a vise which holds the workpiece. Okay. The chuck generally is of a three jaw or a four jaw. They have their different purposes, their uses. See, with the movement, this workpiece is rotating. See over here. Okay. There's the gear attachment or the gear box inside the headstock. Forwarding this. This is the tailstock. Tailstock is generally used in order to support a bar when it is having higher length. Otherwise, there will be an cantilever effect which will result into wobbling of the workpiece. Basically, it won't be rotating parallel to the axis of the main spindle. See, this workpiece is supported by the dead center of the tailstock. Special types of tools may be attached to this tailstock in order to perform machining operation. For example, a drill bit may be attached to the tailstock in order to perform drilling inside the workpiece. See, the chuck is rotating with a workpiece attached to it. Sorry. Yeah. This is the saddle. See, this is the compound rest. It is used for taper turning operation whenever we need to perform a turning operation where the angle generally varies, or we need to get a V-shaped end into the shaft. Okay, there is a cross slide, this portion where we give a motion in this direction, in the inward direction, in order to make the cutting tool interfere with the workpiece. Okay. The total fitting over here, this is known as your apron arrangement or apron box. This apron box consists of the gear which are required for the movement of compound slide and cross slide. Okay. Now, moving further, how metal cutting, now we shall see how metal cutting is performed on a lathe. Let us see a video about that. Now it is on the cutting on a lathe is considered to be a traditional machining process. The first thing is turning operation. Turning is basically reducing the diameter of the shaft. You can see this tool post and this tool, whenever it is interfering with the workpiece, material removal is happening and the diameter is getting reduced. Then comes facing. Facing is about reducing the length of the job. We generally reduce the length of the job. This length is reduced. So material removal occurs from the face of the shaft. So it is known as facing operation. Then taper turning to form an angle along the length of the cylinder. Okay, so let us see how this is performed. See, this is taper turning. See, the edge is tapered, is having an angle. It is not straight turning operation. Okay. Then parting off. after you have finished a particular producing a particular workpiece, you generally cut off that part from the shaft or the rod. That is known as parting off operation. Now chamfering. Chamfering is removal of sharp corners to achieve smooth assembly of the components. You have had seen, like, whenever there is very sharp corner to a particular product, generally the corner tends to break away very easily. For that, a small amount of material is removed from the corner in order to observe smooth fitting of two components. See, from the very edge, a slight taper turning operation is performed in order to ensure smooth fitting of the component. Then comes boring. Boring is performed, not essentially. Tailstock is always used. Generally, internal turning can also be a procedure for making, or boring is a process to actually increase the diameter of the hole which has been drilled. Okay, that can be done by inserting a tool into the tailstock, as well as by internal turning operation. Like, whenever turning was being performed, it is like reducing the diameter. Okay, if it is performed inside a hole and it is intended to take, or the feed motion is generally opposite to what we generally give during turning operation. Okay, let us see. This is when a boring tool or drilling tool is attached onto the tailstock. Now, external thread cutting, it is performed. Yeah, see, threads are being cut onto the surface for easy fastening of any, like, screws, threads on the bolts which we generally get. I think we have had an idea about the different processes generally, or the conventional, very frequently used processes we generally associate with on a lathe. Okay, now before we start our job, okay, first we need to ensure that the serviceability of the apparatus and the instrument. We need to check whether our instruments or the machine tool is performing as per our expectations or not. We need to give dry run to the machine tool in order to check its serviceability. Then ensure general cleanliness of the experimental setup, because it might happen that during machining operation, as this is a power tool, if proper cleanliness is not observed, then it may impair the total machining setup which we generally have, or which we generally use for the metal cutting purpose. Then check the calibration date of any instrument used. It is a very basic thing. Whenever we are going to use any instrument for measurement, we need to check whether the instrument is able to perform, or is able to measure the quantities properly or not. Okay. Now, what we need to do when we say in order to achieve the objective of job number 1, that is step turning on a lathe. See, this is the type of workpiece which we are going to get. This is a cylindrical rod. This is a cylindrical shaft. We have to convert the cylindrical shaft into a product like this, into a pin like this. So, if I may show you, see, what we have is suppose a shaft like this. First we need to, as we can see, this edge is not straight, so we need to face the particular workpiece in order to get a very straight edge. After that, what we need to do is we need to this is the part we need to machine out from the shaft. Okay, and this is the part we need to remove on a lathe. So in order to perform this operation, what we need to do, the steps which are involved in this cutting operations are initially to inspect the workpiece, the raw material, the cutting tool and the machine tool. Then we need to fix the shaft onto the chuck or the workpiece holder on the headstock. Then centering of the workpiece. What is centering? Centering is the alignment of the workpiece parallel to the external axis of the workpiece should be parallel to the principal axis of the shaft. After that, checking of work tool system, whether everything is properly placed or not. After everything has been checked and performed, we should move to the main requirement or main purpose, that is to remove material from the work surface to get the desired output. Okay, then after that has been performed, we need to remove the workpiece from the chuck. It is very easy. Let us see how this step turning operation is performed. See, generally we get a sheet, a graphic sheet like this, where dimensions are given and you need to perform the specified task as given as per the diagram given. Okay, see, this is a step turning operation on the diagram which we need to the dimensions which we need to make out of this shaft. See, this is the workpiece. After proper inspection, it is being loaded onto the chuck. This is a self-adjusting 3-jaw chuck, where with tightening of a particular pin, we ensure that each of the jaw is moving in same direction and in same amount. This is the tool post. This is the hose from where we can give cutting fluid. See, these are the job dimensions given over here. This is a hose, as I was saying, this is a hose through which cutting fluid can be applied onto the cutting zone. This cutting fluid are applied in order to ensure easy cutting of the workpiece. Otherwise, thermal damage may creep in during the cutting operation, which may impair the workpiece as well as the cutting tool. See, there is a very non-standard method of measuring the workpiece. Here he is seeing whether the maximum length of the pin which he needs to make is can be achievable in the length he has exposed. See, this is the cutting tool. With the interference, see, the machining has started. The chips are being flying out. Sorry, no, machining has not been started. Sorry. See, the chuck has started revolving, and with the relative interaction, turning operation is being performed. Turning operation is reducing the diameter of the shaft. A pass has been performed. The material removed can be clearly seen. The color of the workpiece has changed from a rusty color. It has changed into a very silvery color. You can see the chips or the removed material from the workpiece is getting accumulated over here. See, after a pass, a second pass is being performed. Actually, if we need to reduce, suppose 6 millimeter radially, in radius, okay, so we can't perform that operation in one single pass. We need to give multiple pass in order to perform that thing. If we try to do it in one single pass, that will damage the tool severely and the tool might break. So tool failure will occur. Okay. See, multiple passes are being given in order to get the required dimension. See, the final outer diameter is being checked. See, again the diameter is being checked using a vernier caliper. After the outer dia has been cut, what he is doing, he is marking a particular marking a section till which he needs to cut the second part where further dimension or the further diameter needs to be reduced. See, after few successive passes, you can see the step which has been which is very clearly visible. This is the second step. See, half of the task has been already performed. We can clearly see the two different steps. In this way, multiple steps or multiple operations can be performed on a single workpiece and we can get the desired output through a lathe. Okay. Now this brings us to the end of objective 1 or job number 1. Now moving further to objective number 2 or job number 2, that is to make rectangular slot on a block of cast iron on a milling machine. As we have seen on lathe, it generally produces or it generally deals with cylindrical jobs. What if we want to use a rectangular piece? Then we generally require a machine like this, a milling machine, or this task can also be performed on a machine known as shaper or planer. Kindly go through the materials available about what is shaper and what is planer. Now, as I was saying, we need to make rectangular slot on cast iron using a milling machine. So what is cast iron? Cast iron is an alloy of iron similar to that of mild steel, that contains about 2 to 4% of carbon. So the carbon percentage, as I have said, that in mild steel it is around 0.05 to 0.25%, but in cast iron it is about 2 to 4% of the carbon. Okay, then generally they are mixed with varying amounts of silicon and manganese and traces of impurities such as sulfur and phosphorus. It is made by reducing iron ore in a blast furnace. The liquid iron is cast or poured and hardened into crude ingots like pigs, and the pigs are subsequently remelted along with scrap and alloying elements in a cupola furnace and recast into molds for producing a variety of product. Okay, generally this cast iron is considered to be, or is rather, is much more difficult to machine compared to mild steel. They are not ductile, as they are much more hard, and the ductility is comparatively very less compared to mild steel. So the chips which we generally get for cast iron is not in form of long and continuous type of chips. We get very fine and small in size amount of chips. Okay, fragmented type of chips. This is a milling machine where the cutting tool is mounted in this arbor. The length of this arbor, also not the length, the direction of this arbor can be varied, and whenever this workpiece is clamped onto the bed, with the relative interaction of the tool and the workpiece, material removal occurs, as similar to the lathe on the cutting operation on lathe. Okay. Now similarly, before we start the operation, we should ensure the serviceability and apparatus of the apparatus and the instruments, as I have told about previously. Ensure general cleanliness of the experimental setup and check the calibration date of the the instruments used. Okay. Sorry. Now, to make rectangular slots on block of cast iron on a milling machine, what we need to do actually, you may see these are vacant. I need you to visualize what we need to the operations which we need to perform in order to make this happen. Let us open the drawing board. I'm not very good at this. You might have understood it by now, and I'm sincerely learning about how to use a drawing pad. But as you may see, I'm not going in a very good direction. Suppose this is the side view of a particular workpiece. Okay, let me draw in 3D. This is a workpiece, this is a rectangular block. What we need to do, we need to make slots. Suppose this is one slot, this is another slot. We need to cut the slot over the entire top surface. Okay. So we need to eliminate off this portion of material from the block which we have. Okay, I think it is understandable, I believe. Now we have understood about the conversion. Okay, now what are the process in order to perform this operation? Again, inspection of the work material. The dimensions must be properly checked. Like if we want to have a slot of about 100 millimeter and we have a workpiece which have its length of about 90 millimeters, so we will not be able to perform the required operation on that particular workpiece. So initially we need to inspect the workpiece whether the intended task is is possible to be performed or not on the particular raw material. Then cutting tool, the condition of the cutting tool, the condition of the machine tool, whether it is properly behaving or not, whether it requires oiling or greasing, we need to check. After that, we need to fix the workpiece onto the vise. After fixing of the workpiece, checking of the work tool system before initiation of the metal cutting operation, we need to recheck the operations we need to perform. If we don't do that, it might happen that during machining a particular machining of a particular component, the machine stops. Then it becomes very cumbersome to unload the workpiece or to remove the workpiece. Rather, it becomes very inconvenient, as well as very it may be a potential dangerous thing for the operators who are performing the operation or the metal cutting operation. Now, material removal as per our requirement, then removal of the workpiece after requisite amount of the desired tasks has been performed on the work surface. Okay. Now let us see a video how this is made. See, before starting this, in this milling machine, the arbor can be identified, and on that arbor, this is the milling cutter. Now, what is different between a lathe, a single point turning tool which is used on a lathe, and a milling cutter? A lathe tool or single point turning tool is having a single cutting edge, just like a sharpener blade. However, a milling cutter is having multiple cutting edges which comes into interaction with the workpiece one by one. But in case of shaping or planing machine, as I was asking you to read about those, these are single point cutting tool machines. Okay, they employ a single point cutting tool, not like this, a multi-point cutting tool. Let us see.
Gear cutting on horizontal milling machine.
See, this is a workpiece which is being loaded onto a vise. After it has been loaded, it is being clamped firmly to the vise. See, he has now started the cutter which is rotating. Here in lathe, as you may remember, that the workpiece was rotating, but in milling machine the cutter rotates, and with the relative interaction of the cutting tool and the workpiece, see, the chips are, the material is getting removed in form of chips. Okay, this is the feed motion is being given through this wheel. Depth of cut is being controlled by the lever which he was holding in his right hand. Cutting fluid is being poured onto the cutter in order to reduce the cutting temperature or to control the cutting temperature. Otherwise, tool failure may occur very easily. smoke is coming out of the work of the during the machining process, which indicates that the cutting fluid which is being given is being evaporated, as well as very high amount of heat is being generated. The small particles coming out of this are the chip particles along with the cutting tool, cutting fluids. Further, increase in depth of cut is being given onto the machining system for a deeper cut to be performed. See, a slot is clearly visible, having a having a very high amount of width on the workpiece surface. The slot is visible. If we go to the end of the video, see, the slots very clearly visible on the workpiece surface, which has been cut using a milling cutter on a milling machine. Similar slots are yet to be made over here where marking has been already performed. Okay. See, the chips can be very easily identified from here. If we look closely, we may see that the chips over here are very small in size compared to the coil type of chips which we observed while turning on a lathe. Now, this brings us to the end of objective 2 as well as the lecture. The link to the difference between lathe and milling machine, as well as difference between single point and multi-point cutting tool, the video to the link will be given onto in the details the description section of the YouTube video. Also, I will be giving it in the I button. Kindly follow that. Okay, thank you.